All right, cool. Let's get started. See a couple people in the thread at this point. Go ahead, and if you're watching, go ahead and just post something in the thread in Basic Prep. Just let me know you're there. That helps me get a sense of who's around and lets me know that people know where the thread is. It's kind of the main thing. I kind of revisit this a lot for study halls, but I just want to remind folks that the purpose of study halls is to give you all a forum to ask questions. Maybe if you're in premium prep and maybe there were questions you didn't want to ask during class time or something. Yeah, so the floor is open for questions. Obviously, you can't come off mute or anything, so just go ahead and put it in your questions in the thread under the Basic Prep Slack channel. Go ahead and put in your questions there, and I'll take them as I see them. It's fine if you all want to answer each other's questions and have crosstalk. If the thread starts to get a little dense, and you want my attention, just put @Clark in front of it, and I'll probably see it easier that way. So yeah, your questions can be anywhere, anything within the scope of what we're covering on Learn. There are certain questions that I may not want to take on stream, but you're always free to ask, and I might say that I want to focus on something else, but you're always free to ask. And you're welcome, of course, to bring anything from the Python material, from our own material and Learn. So yeah, I'm not seeing anything at the moment, which is fine. So for now, we're just going to go through. I decided to skip the first few lessons because I think they're kind of a sort of a slow start. If people are just starting out with programming and maybe need some more beginner remediation or beginner help, if you're having, you're struggling with the basic concepts, that's fine. We want to give people space for that to be where they're at. Feel free to DM me, whether you're in basic prep or not. Just reach out, and I'll get back to you as soon as I can. And yeah, I'm happy to help outside of study halls as well. Cool. So I skipped ahead a little bit. I think last time we were on basic Python. So I skipped variables, scalar types, and basic operators, and we're in control flow now. So basic Python is just kind of going to go over some fundamental ideas about how the code, what the Python interpreter is, and how the code's going to execute, and just basic things like that. Variables is going to cover syntax for naming pieces of data in your program. Scalar types is going to talk about scalar types are what you might think of as simple types, like types that have a single static value at any one given time. They don't have the ability to change and fluctuate. So the scalar types in Python are integers, floating point numbers, which are both what we think of as numbers, just regular numbers. Boolean values, which have a value of either true or false, and strings. Those are the types that we've covered. There are several other scalar types, but that's good to know for now. And then basic operators just has to do with operators like addition, subtraction, multiplication, division, things like that. So I wanted to get into control flow because this is where we have a foundation in these other things to do some things, and control flow is where things just start to become dynamic. So I think that's a good place to start for now. Looks like we do have a question in Slack. Can I review this line of code? Sure. Let me paste this in. Okay, we've got this line of code. Oops, I don't have my... Oops, that's not going to do. I have to... There's the command. Okay. So 3 mod 12 equals 3. This result can be a little unintuitive if you're unfamiliar with the subject. So what's happening here? I'm not sure exactly what your question is. Are you wondering like why this works in this way? Is my guess. 3 divided by 12. Oh yeah, okay. So I'm familiar with the modulo operator, but I don't know how to get how it got the answer 3. Well, I think you'd say like, let's look at a problem that maybe is more intuitive. So 12 is actually an anti-prime number. So let's look at like 13, something that doesn't have a lot of factors. So let's say how many times does 4 go into 13? So let's look at oh, excuse me, 13 mod 4. Oops. So if we say 4 plus 4 equals 8, let's do it like this actually. Num equals 4. We'll say num plus equals 4. We'll say that's 8. Plus another 4. That's going to be 12. And then let's do something a little different here. 15. So plus another 4. That'll be 16. So if we look here, 1, 2, 3, 4. So 4 can't go into 15 4 times. It goes into 16 exactly 4 times, but it goes into 15 3 times. And then there's a remainder. So it goes into 15 3 times. 3 times 4 is 12, and then 15 minus 12 is going to be 3. So 4 goes into 15 3 times with a remainder of 3. So this gives us 15 mod 4 should have a remainder of 3. Let's actually, oops, let me try to write this. 15 mod 4 has a remainder of 3. So think about how many times 12 goes into 3. Obviously 0, but you still have 3 left over because it didn't go into 3 at all, right? So it goes into, so if we say, let's do the same thing for the first line of code. So 3 mod 12, so we start with 12, and 12 goes into 3 0 times. So we just start with 12 right there. We're done. And how many do we have left over? 3. I think that's the best way that I can describe it. Give me a thumbs up if that helps. Okay, good. That sounds like you're getting it. 7 divided by 3 equals, the answer is 1. It's a remainder, and it's asking 3 mod 12, or 3 over, yeah. Okay, cool. I'll assume you're good on that. This is an interesting question. I can't say I'm super proud of the way I answered it, but it sounds like it's working for you. I should think about how to answer that question because that's an interesting kind of conundrum. It's probably a simpler way to explain it, but All right. Control flow. I'm not seeing anything else. Apology. I know there's some activity up here. I'm not seeing anything else. Yeah, okay. Looks like we're good. If I missed somebody's question, just at Clark, just do at Clark in front of it, and I'll get to it as soon as possible. Okay, cool. All right, so we can get into control flow. We covered control flow, and I'm seeing some folks in Premium Prep active in the thread for today, which is great. Of course, if you're not in Premium Prep, you're also welcome to ask questions and stuff. So for the folks in Premium Prep, this will be a little bit of a refresher. And I want to give some extra space for questions on this particular topic because not because I think it's particularly complicated, but it is important. So control flow is a very central part of problem solving in a programming language. In any programming language, no matter how that language handles conditional logic, like it has to be present in some way, somehow. So I want to do sort of a brief overview for people who might be new to programming or new to Python. Even if you're not, this might be helpful too, if this is like your second language or something. So I've thought a lot about like language design and sort of the process of learning programming. Obviously, as somebody who's in the industry of programming pedagogy, right? That's what my job is concerned with. But I've thought a lot about it outside because before I was teaching, I was learning. So I remember when I was a student, I sort of developed the roots of this, and it was a little more complicated. And I've been able to sort of simplify this down. And this is, I wouldn't say that this is quite a fully comprehensive view of all programming languages, but it's a good template to start with. And it's something that you're going to have, like all of these categories are something that you're going to have to like cover in some way learning any language. And for Python, it is almost comprehensive. So let's call this core programming features or tools like toolbox. So what you're going to want to know, you're going to want to have a strong understanding of the types in Python. You're going to want to know how to write functions, control flow, which is I'm just going to call it conditions, and repetition, iteration, or in this case, I'm going to be specific, loops. There are other types of iterators that are non-loop iterators that essentially do the same job in a different way. When we talk about a loop, we mean something specific that you have a process that executes consecutive loops. So if you think about it, you could lay that out in several ways. Imagine you have some task that you need to repeat some amount of times. If your computer is capable of multi-threading, which I'm just going to say computers are, even a phone is capable of multi-threading, you can do those operations in parallel or you can do them in series. So a loop, this is a little bit of an oversimplification, but because things behind the scenes can get optimized and parallelized sort of automatically without you knowing. But the way we think of a loop is as a series iteration, right? It doesn't happen in parallel. It happens in series, right? So yeah, so we're gonna cover loops because even though they may not be potentially the most efficient, they are robust and simple. They're easy to understand, and you can get a lot done with them. We're also going to cover some later on. We'll cover some non-loop iterators, but for now we'll just do this. So to boil this down in simple terms, we have the types of the language. I'm skipping this in stream a little bit. I'm skipping ahead to control flow today, but if you read the material prior to this, and if you're in Premium Prep, we covered some basic types. We covered int, float, bool, string. Some types that we'll cover later are going to be tuple, list, dictionary, and set. Yeah. I know the way that these are organized might seem a little funky, but there's a method to that madness. Okay. Writing functions, understanding the role that functions play is a matter of understanding like when to use them and why to use them. So what's a function useful for? So a function allows us to write code in one place and then reuse that code wherever we want in our in the rest of our program as many times as we want. So you can think about it as as encapsulating a procedure that we can reuse. So whenever. Okay, so it encapsulates a procedure that we can use whenever. And you could go into more depth with all of these, right? Conditions, or AKA control flow. This is the sort of more formal name for this. I always think this term makes it sound a little more complicated than it actually is. The term control flow just refers to conditional logic, nothing else. Sometimes you'll hear people use it to refer to like conditional logic as well as looping logic. But I think officially, at least my understanding is that it refers only to conditional logic, which is kind of just, I wish we just call it conditional logic because it makes it sound like what it is. So conditions let us run code only if certain conditions are met. Loops. Well, I talked about these. These allow us to repeat portions of our code. Cool. So this is a complete set of problem-solving tools, right? So obviously the types are going to do kind of a lot of heavy lifting, and I would say once you get an idea of what functions are and the syntax for how to use them, and the same with conditions and loops, sort of how to put all those together. And I mean that like how to put them together mechanically, like how the syntax goes. Once you kind of get a sense of that, you don't need to master it, but once you're feeling kind of comfortable with that, the real time that you're going to spend learning the rest of the language is going to be in sort of understanding the ins and outs of the types, learning different methods, learning how to apply them, and learning to synthesize all of this together into a single cohesive sort of problem-solving workflow. Cool. Okay, cool. So I wanted to just give this before we start jumping into things, just to give some perspective on how everything's going to fit together today. So yeah, so we've covered a bit of types, kind of the simpler types, and I'm going to assume that everybody here has some knowledge of that. And apologies if you don't, I don't mean to put you on the spot or make you feel like you're not welcome. You absolutely are welcome. Just to reemphasize, if you want some remediation in this area, just DM me and I'm happy to help. But I'm going to assume some of that knowledge for now, just to get us moving forward and get us into some material that I think would be more challenging and interesting for people. So yeah, I just wanted to put into perspective how all that fits together. We've covered some types, and in Premium Prep we've covered a little bit about conditions. And soon we'll cover some about functions and loops as well. We're going to cover all that, at least, somewhat in the first week of Premium Prep. So you will have a complete set of problem-solving programming tools by the end of the first week. Okay, cool. And it looks like we've got a couple comments here. Somebody's asking that they've been having trouble with extra practice problems, iterations Q1, if I want to go over that at some point. I'd be happy to. Can you send me a link so I can just click on it rather than me having to navigate to it? I'm never sure if I actually got to the right point if I have to click through and navigate. But yeah, if you can send me a link to that in Learn, then I'll be happy to go through it. We have another question. Is it correct to think of a function as a shortcut? A function as a shortcut. I mean, it depends on what you. It depends on what you mean by shortcut, I think. It's a short. You could think about it as a shortcut in the sense. I mean, this is highly subjective. I'm just thinking about how I would interpret the term shortcut in this instance, but it strikes me that you could think about it like a shortcut to the definition of the function. So you define the process in one place, in one part of your code base, and then somewhere else in your code base you invoke that process. So that invocation is somewhat of a shortcut to, it's kind of like, hey, go over here, take a shortcut to this part of the code, rather than having to take the long way around or whatever. But go to this part of the code and execute this part of the code and then come back. So sort of a portal to a different portion of your code. You could think about it like that if it helps. Let me know if that answer was helpful or if you need or not, Okay, cool. Oops. Let's do this. We've got a link for the, okay. And Apple has rearranged my desktops and now everything's a mess. Thank you, Apple. It's not what I wanted you to do at all. Oof, okay. Cool. Okay, so we're looking at iterations challenge question 1. Let's look at this. So we have somebody requesting that I go over this problem. Feel free, if you want me to go through and debug your code, I can do that. Since I don't see any other code supplied here, I'm just going to go through and give a solve to this. Feel free to ask any questions along the way, and I'll probably take those after I'm gone through this. Okay, so I prefer to do all my work out of my text editor as much as I can. So I like to. It's sort of a small thing, but it keeps me kind of on task and I kind of recommend people do this. Like, you get a problem statement, just copy and paste it into your environment. You could do this in Replit or whatever your environment is. In this case, I'm just putting this in a big multi-line string, and I'm going to go through it and kind of change it up. So as I read this problem statement, I'm scanning for a few things. I want to know what the name of the function is, if one is required, which it's right here. So I have to name it this. The description. The description is going to tell me like what I have to do, potentially what I must not do in order to solve the problem, and what I must do in order to solve the problem. So that's going to be do's and don'ts. Do's and don'ts, as well as process, just kind of describing the process, right? If there's an algorithm or something specific. Also, as part of describing a problem, we want to know what inputs does this problem operate on, right? So inputs, this might be a little bit confusing, like, are we conflating this with the input function? I mean inputs in more of a generic sense than that. But the formal word for inputs into a function is parameters. So I'll say input / parameters. So when we invoke the function, we also call them arguments. So you'll often hear me use the word arguments in place of parameters or inputs, even though that's technically wrong. It's a common conflation. Like we all know that calling everything arguments isn't technically correct, but everybody does it anyways. So you'll often hear us use the term arguments sort of slightly out of place. So what are the arguments to the function? So I'm going to actually just put this up front, aka inputs or parameters. And then what is the output? And the formal term for this is the return. Right? So what does a function return? If you think about the return, what does it give us back? So we give it arguments and it returns something to us. So what does it return? AKA output. So I'm scanning for these things. In general, I'm going to look for sort of arguments and returns first. And a lot of times, if you look at the inputs and the outputs of a function, you can infer what it's supposed to do. So I look for inputs, outputs first, and then if that doesn't give me a clear description on how to accomplish that, then I'll kind of dig deeper into the description. So I'm also looking for if there are specific examples given. So saying write a function that takes in two numbers and returns the sum of those numbers. For example, if the function takes in 4 and 8, it should return 12. So if there's specific examples given. In this case, there is a specific example down here at the bottom, but we'll get to that in a second. Okay, cool. So I'm just laying this out to kind of show you, like, when I'm reading a problem statement, these are kind of the things that I'm looking for. And if there's anything easy that's kind of just given to me, I'm probably going to write it down as soon as possible. So as you're reading problem statements, kind of think about things in these terms, and you may think of other things, and that's fine too. All right, so write a function called get index of. So I'm going to do that right away. Just get that out of the way. We'll print it. Get index of. And then, so this is the invocation. Remember I was talking about you have the definition part and then the invocation part. So I'm invoking something that doesn't exist, but I tend to like to do this first because it's hard to make yourself do it when you're like 3 or 4 lines into it. It's good to just get it out of the way and just have it there as you work later. Okay, get index of, and I'm just going to pass here, run my code, make sure I don't have any syntax errors, didn't forget anything. Okay, good. Write a function called get index of. Given a character and a string, the function returns the first position of the given character in the given string. Okay, so given a character and a string. Okay, so this, I read the word given as given what's given to this function. In other words, arguments or inputs. So I already see some arguments and inputs. So given a character and a string, so it looks like it takes in 2 arguments. I'm going to call it ch for character and st for string. Oh, sorry, I just threw in that pass. So all pass does is it's a placeholder. So it just means that I'm going to come back and I'll delete this and fill in the code. The reason we need a placeholder, you might think, well, why not just do this? This is incomplete code, which is, you might think, well, that's fine because you know, we don't have a fully finished solution yet. But I do like to just have the code like complete in a sense. This is incomplete in the sense of like it's syntactically invalid, right? So this says indentation expected an indented block. So in case I want to like do anything else as I'm thinking through this, you know, maybe I want to like check something about the input as I'm writing a test for this and kind of like do a little work, run my code, check something out. If I don't use this pass, then I'm going to get an error, right? So in terms of like saving me potential work later and thinking, oh, I'll need to go back and put in a pass because I actually need it now, I'm just going to be sort of preemptive and just put in a pass right away, if that helps make more sense. Am I using st to avoid confusion with the command for str? Yes. So the reason I'm not using str is a built-in, it's the type identifier, it's the name that Python uses for strings. So we would call this a string. Python calls this an str, which we read as string. So there's also a function by the same name as type identifier, so I don't want to override it. Oops, excuse me, I had something in my eye. I poked my eye. Apologies. And then ch, a lot of times people will use chr or char. I work in other languages that use char also as a built-in that I don't want to override, so it just looks wrong to me, and I can't make myself do it. So I know ch is a stand-in for character. It's kind of useful to like think of like how do you take a shorthand, you know, or how do you express something of a given type without overriding the built-in type. Like go through the built-in type names and think of variable names that you can use, maybe 1 or 2, just in case you need a couple or want to change things around or whatever. So yeah, I kind of will default to ch or st for strings. Sometimes I'll do txt for text, which to me reads as string. It kind of has the same meaning. So actually I kind of like txt better. Okay, cool. So where were we? So given a string and a character and a string, and I see this, I'm going to just copy this test in, because that's basically just going to give me a test. So given this test, or given this input, right, given an A and this string, this function should return the index. So it returns a 2 because the 2 is the index of the first A in the string. So our first index is 0, our second index is 1, our third index is index 2. So indexing uses zero-based counting. Apologies if this is a little out of the scope of what we've gone over. We will be getting to this tomorrow. We'll be getting into lists and therefore indexing as well. And I'll cover indexing with strings as well because it works the same as it does in lists. Okay. All right. So this is a good example. Given a character in a string, the function returns the first position of the given character in the given string. So this is what I would consider the description, but notice that it's describing what it should do by telling me what it takes in as its inputs, a character in a string, and what it gives back as an output. Now, this is not a specific example because it doesn't say, given the letter A and the string, hey there, all right, hey, that doesn't have an A in it. uh, Given the character E and the string hey there, it should return 1 because E is the first, right? It doesn't give us a specific example. It does give us a specific example down here. So this is what I would call a general description, and it's a description by way of telling me for these inputs, it should return something of this pattern, right? So this is kind of checking a lot of boxes here, right? And then we have some notes. So strings are 0 index, meaning that the first character in the string is at position 0 or at index 0. So that's one thing. When a string contains more than one occurrence of a character, it should return the index of the first occurrence. We don't need to worry about the other occurrences. If the character does not exist in the string, it should return 1. That's interesting. Do not use any of Python's native methods. Yeah, because there's a method that'll just do this for us. Dot index. Cool. Okay, let's get to this. So I have an example. I have an idea of what this should do. So let's just do it. So this tells us something that's interesting. If the character doesn't exist in the string, it should return 1. So that's an edge case. So I'm just going to handle that edge case. You generally want to handle your edge cases first thing in the function and then do the main body of the function after that. Sometimes you need to handle edge cases like in the main body or after the main body of the function. Occasionally that'll happen, but most of the time you can handle them before the rest of the function happens. And if you can, you should do that. So I'm going to say if ch not in text, return 1. So we can just check. This is called a check for membership. So ch in text. I forgot to mention. Oh no, well, I didn't forget to mention. I didn't mention this in the Boolean operators section because it kind of pertains to strings and lists and collections. So we'll talk about checking for membership in the next premium prep as well. So we'll say if the character is in the text, this is going to give us a true or false back, right? So if we have a string hello world and we're looking for z, right? So if z in hello world is going to be false, right? Because z is not the character z is not a member of the string hello world, right? So we can also invert the output with a not, and we can do it in line, and it reads nice and Englishy. So if the character is not in the text, then we can just return 1. So that's nice and easy. If the character is in the text, this will be false. This return will not happen. And we'll move on. Okay. Other than that, let's just do, so I know I need the index. I know I need to return the index. So I'll just say for, shoot, I usually, if I'm iterating through a string of characters, I usually call it ch. I'm going to call this ch n, chin, chin, because it's an input. So for our input ch, so if the chin is not in the text, then I'm going to say for ch in text. It's kind of becoming a comedy of puns or something. I didn't mean it that way, but so for the character in the text, if ch equals ch in, this is confusing, I'm sorry. Let's call this ch arg for argument. So if ch equals charg, if ch equals charg, then we'll return the index, which I'm going to call I. So I know since I need access to the index so I can return it, there's a function called enumerate that will just give me access to the index, and I can say for I, which is my index, for I and character in enumerate text, if the character is equal to the character input into the function, then I'll return I. Yeah, and then if I make it through this whole function, I can actually just return 1, and that means if I make it through this whole for loop, that means that the character was not in the text after all. So I don't need to actually explicitly handle this edge case. So when you need to explicitly handle an edge case, it's best to do it up front. If it can be handled by the program logic, it's best to just let the program logic handle it naturally. So in this case, the program logic can handle it naturally, so I actually don't need that edge case, and I can just return 1 if I get all the way through the loop. So it's a little bit of juggling there, but I'm going to do it this way. And of course, you could do it whichever way you prefer if you want to do it a different way. Cool. So that should work. I see some activity in chat. Let me just submit this and see if this is going to work. And oh, did I? It should return -1. So that must have gotten. Oh, okay. That got split over the line. So that dash, I didn't see that. So this should return -1 if it's not a member. Okay. -1. There we go. Correct. Okay, that works. Cool. Hope that was helpful to the person asking the question. Oh, and they did supply some. They did supply some code. So let me go through that code. To the person who asked this question, give me a thumbs up in chat if that was helpful, or let me know if you have any follow-ups. I'll look through your code really quick and give it a quick debug. For if char not in string, return -1. Yep, here's your edge case. That's great. Else for index val and enumerate char and enumerate string. If val equals char, return idx. Yeah, this appears to be the same logic that I had. I wonder if is that not working? Perhaps I'm missing something, but that appears to be the solution that I have. It looks like that solution works, so there's nothing for me to debug, it looks like. Huh. Okay. Just looking through the questions in Slack here. Give me just a second. I believe PEP 8 does. I mean, PEP 8 is sort of, yeah, it's like a tome of best practices, sort of. I mean, officially it's style guide, but so sort of more of the, I guess it's more concerned with aesthetic than anything. But yeah, I mean, best practices. Cool. Is return the same as print? Ooh, this is a great question. We have a question, is return the same as print? So return is not the same as print. They can be, they sort of have there's a similar idea, which is that print gives us output to the terminal. So what print does is it makes the thing that we pass to it, it makes it visible on the terminal. What return does is it tells, so return only applies to the inside of functions. If I have a return outside of a function, I'm actually going to get an error that tells me exactly that thing. If it runs, okay, here we go. Return, the error is syntax error, return outside a function, right? So there's a special error just for exactly this thing. So you can't have a return outside of a function. A return is out of context. It needs the context of a function. It specifically bears on functions. It doesn't make any sense outside. So what does it do? It tells the function that I want to output this thing, right? So if it for example, on line 66 here, if at any point in running through this or looping through this input text, if any point the character from that text is equal to the character argument value, if that expression is true, then I want the function to output I, right? So when a function encounters a return, when it runs that return, it stops executing any code. So if I'm in the middle of a loop, if I'm going to loop through 20 things and this condition is true on the second try, I'm going to return whatever I is, which is going to be 1. I'll return 1, and it's not going to loop through and return any other values because it already gave us an output. So what would it mean for it to continue to give us output, right? So we capture the output that it gives, and then we move on. If I wanted to, like, there may be multiple instances of something, so you might think, well, I might want to like return a collection of things. Well, we'd have to use a collection type like a list or a tuple or something. I'll use a list, and we could say list.append I. Append that to the list, and then return list. And in this particular case, we would need to handle the since I lost the return here, I would need to handle the what's the other thing I need to do? I need to handle the edge case. I don't know what's wrong with my brain today. Handle the edge case up here. So if charg not in text, return -1. And you might think, like, I mean, at this point, just returning -1 if it's not a member of the text is just an arbitrary decision. In this case, it kind of makes sense to just return an empty list because there were none of those characters in the text. So this kind of seems like valid behavior to me. So that's sort of the answer. If you want to return multiple things, like it needs to be collected into some other type in some way. So you might collect things into a list and return the list. You might, perhaps you want to return a list as well as the length of the list, right? So here's another thing that we call multiple returns. So if you want to return literally two different objects, we can return the list and let's say the len list, right? And that'll tell me how many times that char arg appeared in text. So yeah, that was a lot of answer. The answer to the question, a return and print the same thing, is no, although they do, there's a similar idea in that they both give a kind of output, right? So return specifies what the value of the function is going to be. When this function is done executing, it's going to have whatever the value of list is and the length of the list. It's going to output those two things together. The kind of output that print gives us is visual, in that it writes that text as text to the terminal. It makes it visible on the terminal, right? So we can have a function return something and it doesn't necessarily print onto the terminal. That's what's happening here, right? So this function returns something and it doesn't print onto the terminal. We capture it in output, in this variable output, right? We could maybe even unpack this and say list and then ln for length, and then we could utilize those values and say for ch in list print ch or whatever, like we could do something with this. So I can capture the output of this function and I can utilize it in a number of different ways that may or may not have anything to do with printing it out to the terminal. Whereas so that's what it means to have a return. It gives it that value and we can use that value in our program. Whereas again, print just makes something visible on the terminal. Okay, cool. I feel like I'm belaboring the point. That's a great question, and I just wanted to give it sort of its due diligence of an answer, but I worry that perhaps I've belabored the point too much. Okay, I will continue. FYI, return -1. It's returned. Also, sorry if this was out. No, this was not out of scope. This is a great question. This problem, yeah, this is what study hall is all about. Being able to take people's questions, and we can see different code and different ideas and things like that. So yeah, thanks for bringing a question in. All right, this helped me. Good practice to know along with everything else. Da da da. Ah, yeah. Yeah, that's kind of funny. So there's a remark here from the person who asked the question, asked this question about how this actually worked. I think there's cache that gets mixed up. Yeah, I think sometimes the browser can get confused and like learn can get confused about like what its input is specifically. So if you're looking at a solution and you're like, this should really work and it's not working, copy your solution. This is one of the reasons I say to like work out of like a text editor or Replit or something. So copy it and then you can do reset input and then maybe refresh the browser page and then paste it in again. Oops. Well, of course this does something else. I'll just leave it reset for now. That's fine. Oh, I can do that. I can just Command Z my way there. And that way it'll remember it. So yeah, sometimes that can happen. It's pretty rare, but it can definitely happen. Cool. This is a great study hall. I'm having a great time. I hope everybody's having a great time. Hope this is useful. Appreciate the questions. I'm not seeing any questions at the moment. Apologies if I missed one. I do my best to like keep a note that questions are coming in, but yeah. Feel free to ask anything else. I'm not seeing anything at the moment, so I'm going to go back to control flow stuff. Yeah, feel free to pop a question in if you want. All right, so control flow overview. So I like to call control flow conditions. I will refer to this as conditional logic or conditions, because control flow just refers to being able to execute code when something is true or false, right? So you have some value. Perhaps you want to do something special if that value is within or above or below some certain threshold that maybe is specified or set dynamically somewhere else, or maybe it's just baked in, it's a constant. And you want to execute code under the condition that that number is above that threshold or something. And that's just one example. I mean, there are many examples of ways to compare things, to get Boolean values, to tell if something's true or false, to use to control the flow. So that's control flow. So the keywords here to remember are if, elif, and else. There are 3 conditional keywords: if, elif, else. We can chain these together to make sort of groups of conditions where we say, okay, we may want to execute one of these lines of code or one of these groups of code. And chaining these together will make sure that we only execute one of them, right? So if I want to start a chain of conditions, I can start with if, and then whatever my condition is. Condition, you might think, well, what can be a valid condition? And I've said this before. You'll probably hear me say this many times. But a condition is just any expression that gives us back a value of either true or false. So it's pretty simple. Just anything that gives us a value of true or false, including true or false, right? This is not a dynamic condition. It's a static condition because it'll never change. It's not very useful to just say if true. Sometimes this is useful in like debugging. If you're like expecting something to happen and you just like want to make it happen without altering your code, you can just do an if true and just make sure that that line is going to execute. Or if you're worried that it's always true and it shouldn't be and you just want to turn it off temporarily, you can say if false, something like that. But that's not really generally how we write our code. We'll write our code in some way. We'll give it an expression that's going to give us true or false back dynamically based on other values that may change, right? Because with an if, we're checking to see something that may or may not be true. Otherwise, if we knew it was going to be true or we knew it's not going to be true, it wouldn't be useful to check it, right? So you want to make sure it's dynamic, and you want to make sure it's going to give you back something it's going to give you back true or false, or something that can be understood as true or false, according to the constraints of your program. So let's do that threshold example. So let's say we have num, we just have n, which is some number in our program, and let's say n is like 20, and we have some threshold. And threshold is equal to 100, and we'll say if n is greater than or equal to threshold, then we want to, I don't know, we just print, let's just print, well, I'm going to be lazy, we'll print n is greater than or equal to threshold. Okay, so let's run our code. And you can see what's going to happen here. Right, n is 20, threshold is 100, 20 greater than or equal to 100 is false. That is a false statement. It's not true. So this line of code will not execute. So, maybe there's something, something other, other dynamic part of our code that's setting these values. Obviously, this as it's shown here is not very useful because, I just baked in these values. I just set these values as what they are. So, of course I know what the outcome is going to be. But we can pretend that something else is setting these values, right? And then I can change this and say if n is 200, obviously 200 is greater than or equal to 100, specifically it's greater than, and it says n is greater than or equal to 100. Cool. So we could do this, and I gave a similar example before. Oops. So let's do this. We'll do this n is greater than 100. If we could say elif n is equal to 100, n is 2 threshold. Oops, I said 100. I'm at threshold. Else n is less than 100. So n is less than threshold. And let's test our logic here. Let's set n as 20, and let's put all this in a for loop. Let's say for, I know I'm talking out of scope, but we talked about for loops a little bit today. So let's say for n in range threshold plus 1, and let's actually do threshold minus 3 to threshold plus 3. Let's do that. So I'll have a for loop, and I'll just get rid of n there. I'm using threshold plus or minus 3. Oops, I meant this to be minus 3. And then we'll just see what it prints. It's going to give us different values for n. Right, so let's print the value for n. So we'll say n equals n, and I want to print this in this string, right? This string n equals, and then I want to print the value of n. Right? So actually, this is way easier if I just do this. There we go. Okay, so it says 97 is less than threshold, 98 is less than threshold, 99 is less than threshold, 100 is equal to threshold, 101 is greater than threshold, 102 is greater than threshold, right? So this is giving us sort of dynamic values for that, for the identifier n, for the variable n. Cool. Basic example of control flow. If statements. I feel like I probably went over this. Yeah, so this is just kind of showing us the anatomy. We have our conditional keyword, we have our condition, and then we have our consequent here. Looks like we've got a question as well. Great. Come on. I'm having trouble scrolling here. Here's a strange question. Instead of L if n equals threshold, could we write the same code like so? Okay. So I'm gonna paste in the contents of this message. Oops. So could we write the same thing like this? Yeah. So this is asking, can we? And go ahead and confirm if this is what you're asking. Instead of saying if else, can we say if else? In this particular case, you can. But I want to point out that this is actually logically different. In this particular case, these are going to work the same. In this particular case, we're going to get the same. I think we're going to get the same answers here. Let's just let's verify that. This is the answer I got before. Oh, okay. Excuse me. This is going to act differently, actually. Yes, yes. Okay, of course. This is going to give us a different answer. So for this code, I got, this answer. And for this code, I got this other answer. So let's see where things get weird. Okay, so 97, 98, 99, we know those are all less than 100, and our program agrees. So let's just get those out of there because we know it's good on that. 100 is equal to 100, so that's great. We know that's good. 101 is greater than 100, that's true, but it's false that 100 is less than 100. So this is giving us a problem. So what's happening here is when you chain conditions together with if, elif, and else, remember else and elif are alternatives to the previous condition. So if starts a chain of conditions, else ends a chain of conditions. If the condition in the if, let me rephrase that, when the condition in the if is false, the else will be run, will execute its consequent, right? So what happens here is we have n equal to, what is it? N equal to 101, and then we say, is 101 greater than 100? And that is true, right? So this is the beginning and end of one chain of conditions. So let's call this chain 1 start, and chain 1 stops right here. So it starts here, the line below, and it stops here. Actually, let's do it like this. So we'll put it on the line where it starts and stops. So chain 1 starts here, and then chain 1 stops here. Chain 2 starts here, and oops, that's chain 1. Chain 2 starts here, and oh gosh, I'm fighting my shortcut keys. Chain 2 stops on this line. So 101, it's true, is greater than threshold. 101 greater than 100 is true. Print in is greater than threshold. 101 equal to threshold is false. Therefore, 101 is greater than threshold runs. So that's how that works. So we want to chain these together since there's only one that can be true. We can't make this one an else because we need to check a condition that it's equal, right? So we have to say elif. Other languages will say else if like this. Python needs, wait, that highlights correctly. Is that going to work? There's no way that's going to work. Right, that's invalid syntax. It's funny because the highlighting at least looks correct to me. So the parser doesn't have a problem with this. Well, that's interesting, but it's a syntax error, so the parser must have a problem with it. Anyways, yeah, else if is not valid, but elif is, and elif is just short for else if, right? So else, the L part, the L in elif means if the previous condition was false, the if part means check this condition. And then else means, okay, given that all of the other parts of the chain were false, if nothing else was true, then just do this instead. This is a great question. I think this particular thing is really worth sussing out because, yeah, I mean that's something that you're gonna need to have a solid understanding of to do control flow properly, is when to use consecutive ifs, because to be clear, there are cases where you use if this, do this, if this, do that, right? There are cases where you'll have either an if all by itself with no elif or no else after it, or you'll have consecutive ifs like if, right? So we could make a quick sort of pattern list of patterns that are possible, right? So we can have if, which begins and ends a chain, just all by itself. We could have if, which is two different chains, right? Etc. Right? We could have as many ifs, right, as we want, but like these are different chains of conditions. We can have if elif with no else. That's fine. Or let's actually say if else. Let's do if else first. We could have if elif else. We can have if elif as many elifs as we need else. We can have if elif, and we can have if elif followed by as many elifs as we need. Right? I think this is a bit scratch. This is a bit quick. I'm not sure if I'd want to commit to calling that a fully exhaustive view of how you can chain everything in every possible way. But it gives you some idea, right? Like there are times when you just want to check one condition. If it's true, you want to do this thing, and if it's not, you don't care. You don't want to do anything. You want to just move on, do something else. There are times when you want to check two things, and they have nothing to do with each other, or they don't have necessarily an exclusive relationship, where if one thing is true, the other one can't be true. So you only want to do one thing. Perhaps both of them can be true. So perhaps they have an inclusive relationship where both of those conditions can be true. So if is a totally valid thing, there are problems where it makes sense to use two ifs consecutively. There are problems where you want to check a condition and you want to do one of two things. If the condition is true, you want to do this thing, and if it's not, you want to do this other thing, right? And the reason that this is different than just a solo if is if you have code for when it's true and you want to run the code for when the condition is true, but not the code for when it's false, and you want to run the code for when it's false, but not the code for when it's true, like they're exclusive either one or the other, then an if and else makes sense, right? You don't need to check another condition. You just need to say, okay, well, if the previous condition was false, I'll just do this other thing instead. If elif else, just 3 in a row like this, or if elif elif, as many elifs as you need, and then an else. This is going to give you, elif is going to, the condition of an elif is going to be checked if all prior conditions in the chain were false. And then if it's true, it's going to execute. If it makes it all the way to the else, then the else is going to execute. You also, it's important to note that you don't have to, if you have an elif, you don't have to end it with an else. You might want to check 2 or 3 things that are exclusive of each other, but if none of them are true, you don't want to execute any special code. You don't need an else at the end of it. And you can just continue on, right? So learning how if, elif, and else relates, I mean, it might seem complicated. I think just playing around with it, seeing what gives you an error and what doesn't, just taking some time to just like think of some random conditions and just play around with this. I think you can suss this out in a short amount of time. So yeah, exploring things like this I think is great. Anyways. Okay. So you're saying in this particular case you can't use consecutive ifs? That's what I would say. You wouldn't be able to use consecutive ifs in this particular case. Okay. Cool. All right. One thing to note here, if you ever want to know if something works, I think, and I see somebody saying like at first glance I thought it would work with 2 consecutive ifs, but I see now that it won't. So to the person asking this question, I haven't spoken with you. I don't know if you like what your background is with programming. So apologies if my assumption on this is wrong. I get the sense that you're like this is perhaps your first programming language, and if not, then perhaps this is a workflow perspective that I can share. I notice a lot of people will want to approach this in a way of like wanting to think about, be able to look at the code and in your mind think about what it's going to do. And I won't diminish that as a useful skill. I mean, it's nice to be able to look at code. Okay, it is your first language. Cool, yeah. So yeah, so and I think this can be a useful perspective. Even for a lot of people who have been programming for a while. It's obviously it's nice to be able to like look at code and be able to like think through it and say, oh, this is what this is going to do. It's useful to be able to do that, but it's also not, let me put it like this, it's not the central skill that it might seem like it is. In a lot of other fields of academics, I mean, even I would say most of the rest of STEM fields, like, put the burden on you, the thinker, the human, to do the work of validating the work. In math, if you're studying math, if you're getting a math degree, like, you better be able to think through the problems. That's the point. And with programming, while it's useful to be able to think through your code without running it, you have something working to your advantage, which is the computer. Programming happens in the context of a computer. I mean, at least for my purposes, I think that's a bit of a subjective statement, but I'll just say it does, and for my purposes. Learning Python happens in the context of having a computer, probably, where you can run code. So I would say, and I would call this a central skill of becoming a good programmer, learning how to ask the interpreter if something will work, becoming comfortable with running your code and having it give an error. So to be clear here, I don't mind if if there's some piece of code that you could have run and you ask me instead. That's fine. I mean, that's what I'm here for, to weigh in and try to give explanations for why things work that way. Um, if you send me a piece of code and say, why doesn't it work? The first thing I'm going to do is like copy paste it and like run it and see what error it gives me. If I'm looking at 10 lines of somebody else's code and it's not working, at this point I've been programming for a number of years, like I have a pretty good chance of like being able to catch the error quickly by eye, but often I don't. And I mean, part of that is I think that I'm dyslexic, and that's a bit of a challenge that has extra challenges for me. But um, also I think it's just like it's kind of a it's not the main skill of that you need when you're programming. So I just wanted to kind of plant the seed, like uh, get into the habit of this is not just at the person asking the question. This is, I think especially for newcomers, people who are new to programming in general, and I think for a lot of people, this is a really effective mindset. Get in the habit of like checking your work by running your code constantly. I mean, the worst that's going to happen is you're going to get an error, and that's, I mean, like, oh no, like I get errors all the time. I get errors while I'm teaching class, and I'm like, oh, okay, well, this didn't do what I expected it to do. And I'm not gonna lie, while I'm teaching, it can be a little bit embarrassing. I can be like, okay, I'm trying to get an example. I want this to work now so I can finish the example. But often, I don't work that hard to avoid them, because often it's useful for people to see, like, yeah, I get errors. We all get errors. It's part of the thing. It's part of the thing that you're learning. You're probably not going to stop getting errors ever. Um, I've heard of people that'll write hundreds of lines of C++ and compile it and it runs the first time. Like that's like a miracle. It's like a legendary thing. It's not a normal skill. Um, it's like being a musician and having perfect pitch and being able to hear like 15 different parts in your mind and like write down a symphony from that, like just as you dream it up. Just that's great, but that's not the skill that you're supposed to develop studying music. If you have that skill, then that's awesome, but for the most of us regular people, that's not what we need to focus on. So yeah, no worries. Feel free to ask me as many questions as you want for whatever reason. I'm happy to take questions. I have fun taking the questions, and I think it's useful to like talk them out. It's useful for other people to see solutions. It's useful to get other perspectives. So by no means should you take this as like being averse to asking me or anyone else questions. But it's also a good perspective to be like, okay, how can I check my work? How can I validate what I just did? If I'm working on a problem that's challenging for me, I'm running my code. I mean, a couple times at least per line that I write, and probably most of those are resulting in errors. Well, maybe not most, but yeah, I don't as often make like syntax errors anymore. But you know, the funny thing is, after the way that I've learned to be, as good as I am at validating code by eye isn't really because I tried to do that. It's because I ran my code so much that like I've seen every error that Python will give, out of using the features built into its standard library. Like like if you think about it, like every time you get an error, it's an opportunity for you to go, okay, this is how this particular thing fails, and it's an opportunity for you to understand why it fails. So if you think about like how can I get as many errors as I possibly can all the time, I mean, you can go through and try to like write different variations of broken code just to see what errors you get. And after a while of doing that, you have a sense, you see an error and you're like, oh, an unexpected EOF, well, I probably have a missing parenthesis somewhere. Um, or, oh, a name error, well, maybe I deleted this variable at some point earlier on and I forgot to recreate it. Or um, maybe I misspelled something. Or a syntax error, well, I probably forgot a colon somewhere. Let me go check, and yep, here's a line without a colon on it. So things like that, like after you see a lot of errors, you develop these like quick responses to what those are, and that is a much easier to learn skill, and it's more useful because of that. It's really useful to just be able to like catch an error or like solve an error really quickly. So, anyways, again, I'm off on one of my tangents. Apologies. Okay, cool. So we're about at time. This is close to the time that we normally will wrap up. So yeah, again, hope I didn't put you on the spot with that answer, but I thought it was a good opportunity to like just talk about that perspective, because I think it's an important perspective for people to start getting into earlier, with like validating your code and stuff. So yeah, this was a lot of fun for me. I do enjoy doing these. Look forward to Monday when we can meet again, and hope everybody found this useful. DM me if you have any follow-up questions, or if you have any questions at any point with our material, or even like questions from Code Wars. I'm happy to help. I'm happy to arrange mentoring meetings with anybody who wants that. My schedule is really open right now. We just had a DSI cohort start, and we stopped interviewing for the February cohort this prior Monday. So my schedule is much more open, and I'm ready and available for mentoring. So please reach out. Don't be a stranger. Give us a like or a comment and a subscription on YouTube if you feel like doing that. And yeah, I'll see you on Monday, or I'll see you on Saturday if you're in premium prep. So yeah, have a good rest of your night. Bye bye.